So we're on the chapter 5. It's called, I think it's called sampling methods. Yes, it is. So at 1 o'clock today, you'll get your tests. You can do it anyway up until Sunday. I only put it on early because there's 1 or 2 people that kind of suits their schedule. We know what a population is, isn't a population? Everybody that you're interested in asking the question about. That's essentially what that is. So if I was interested in who's going to win the governor's election in Washington State, then my population would be all people who can vote in Washington State. For instance, you shouldn't ask me. I'm not allowed to vote in America. I'm not a citizen. That would be a population. If you were interested in the opinions of high school students in America, wouldn't the population be high school students in America? Right. You wouldn't go over and ask, high school students in Japan if you were interested only in one group. Now, a sample is essentially a small group of people from the population that you actually do ask. If you don't ask that, the other choice is called a census. And census is actually really, really accurate, because in a census, you actually ask every single person, or at least theoretically you should try to. So you can imagine if you're interested in the average weight of high school students in Bremerton, a census would be you found every single high school student in Bremerton, which might be quite difficult to do, but you did it, and you weighed them all. Now, in that case, won't your answer be perfect? That is the average weight of high school students in Bremerton, give or take. Whereas a sample might be, I'll only pick 200 of them and use that. Now, a guy we haven't talked about is called a sampling frame. Now, in a perfect world, the sampling frame should be the same people as the population. But sometimes it's not. So what is a sampling frame? A sampling frame are the people you could choose for your sample. So let me give you a story of why that might not be the same as the population. Suppose I'm interested in the average age of high school students in Bremerton. Right? I'd like to know what the average age is. And I decide to get my sample students who go to high school in Bremerton. So I go to, whether it's Bremerton High School and all the other kinds of ones that are in Bremerton. And you might say, well, that's a good sample. What students do you miss if you only go to high school and ask students who go to high school? Because there are a certain subgroup of students that never get asked and so would never be in my sample. So this is the sampling frame. I'm choosing only students who go to high school. Who am I missing? Because I'm interested in the average age of students in Bremerton.
Homeschool kids or
there you go.
Kids.
High school kids you're missing. I don't know if we could, yeah, you could say elementary. Couldn't I miss running START students if they do every single class at a community college? So you have to be careful, because if the people that you don't have in your sample, right, because the way you've picked your sample, you never ask them, and they are significantly different than everybody else, won't your answer be a bit out because of that? Maybe homeschool students tend to be a little bit younger, and it's only when they get to their senior year that they actually go to high school, right? You finish off all the bits and pieces you can't do in high school, right? I don't know an awful lot about homeschooling, but I would assume that it might be quite difficult to do advanced chemistry or physics class, or it might be difficult because the parents aren't up to it to do, high calculus classes, right? So, their mother or their dad, whoever is actually doing the homeschooling, might not and understand that they're not able to do it. So you would miss those students. That would be bad. Suppose I'm interested in who's going to be in the next governor's election. And the way I picked my sample is by phoning people. I randomly phone lots of people. Who am I going to miss then? Because my sampling frame is people who own phones, right? So who are you going to miss?
People who don't have phones.
Right. And probably also people in X directory, because you don't know what the phone number is, right? Those kind of people. So do you see that sampling frame is the people that you could ask in your sample? And that might not be the same as your population, right? If a sample is going to be good, shouldn't the sampling frame be pretty much the same people that is in your population? Make sense? Right. So now we've got a whole load of different methods to sample people. And that's kind of where I'm going to start all this. Well, I've already done it, all this talking. First kind is called a simple random sample. SRS. And a simple random sample is a sample, obviously, where any person in the population has the same chance of being chosen as any other person. So simple random sample is a sample where any person in the population could be picked for that sample. And that any person in that population has just the same chance of being picked as any other person. That is like the holy grail of sampling. That's the sampling method you should choose if it's feasible, right? There's lots of practical and financial reasons why it isn't feasible, right? Suppose I wanted to do a simple random sample to find out the average weight of an American. Wouldn't I have to know where every single American lived and then just randomly pick 200 of them? Then when I have to go to them and physically, I guess, weigh them on the scale, because believe it or not, don't people lie when you ask them their weight over the phone? And I'm not going to go sexist and say which sex tends to lie more than the other, but there is evidence to say that one sex tends to lie a little bit more about their weight than others. Also, they tend to lie a little bit more about their age than others. For some reason, stop there, still got a job, don't lose it, right? So that's the thing we've got. Can you see how just financially and physically difficult it is to do a simple random sample? Because to be able to do it, don't you need to know everybody in the population that you're interested in? Now, you could say, well, could you maybe do it for smaller situations? yeah, you could probably get away with it if it was a smaller situation, right? So if you were interested in, let's think, the average age of cops in Bremerton, right? Any kind of cop who works in Bremerton. That's a reasonably small population, isn't it? You could get a hold of the data from their, their work records or whatever you want to call them, right? And randomly pick 200 of them, right? And that would do it. So simple random sample is the perfect one. Why is it good? Normally when you pick an SRS, as long as the population is big enough, it tends to be a fair representation of the population. Can you imagine if you just randomly pick 400 people, isn't there a good chance if it's a random sample like this, that they're pretty similar to everybody else in the population? Occasionally weird things happen, but that's true about all of them. So there's really, the only drawback to doing this is cost, and it's not always practical. Now, what are the good things about a simple random sample? You get good data from it. And good data means you get good conclusions, right? Accurate conclusions. We like simple random sample. They are our friend. So maybe do one more. Suppose I was interested in finding out the views of Olympic College students, and I wanted to know things like the quality of education they received and how many credits they took and all sorts of things like that. It's not too difficult to get a list of all OOC students, right? It's on a computer somewhere, right? Probably records and registration, I've got it. And couldn't we simply get a little program where we ask it to randomly pick 100 students? And then we contact those students, probably by phone or email, and ask them what they want. Or you get one of those paper things. Has anybody actually took part in that? Because the college does that. Any of you been in a class where you've been handed something and it asks you a whole load of things about yourself and the college experience? I wonder if COVID has kind of screwed that up. We normally do it once a year, so maybe it's just you've dodged the bullet there. But let's move on, oops, to what is called a systematic sample. Told you today is going to be all about listening to me. Right, a systematic sample is when you choose people, this is going to be pretty obvious, in a systematic way. So that you choose people for your sample in some systematic way. So give an example how you might do that. You have everybody at Olympic College, and you have A to Z. And you find one person whose last name starts with an A, and one person whose last name starts with a B, and one person whose last name starts with a Z. And that's your sample. Do you know there's some system to how to pick it, right? Suppose that you're collecting data on people in houses, right? So you've got a huge long street, lots of houses. And you don't want to go and pick every single house. So what you do is you pick house number 1, then house number 10, then house number 20. I guess I should call that 0, but there's no one. House number 30, right? And you just walk your way down. And basically, don't you just sample every 10th house? Maybe they're not called 10, 20, right? You pick that house and then you walk 10 houses later, you go and you knock on the door and you do your thing, and then so on. So if there's any kind of structure that is kind of got a system to it, it typically is done if you're kind of lazy and you don't have a lot of information, right? So aren't you hoping if you do the house one that the houses, you're going to get rich houses and poor houses and expensive houses and cheap houses, and you know, you're going to get all the variation. You would hope. I guess it's time to pause for a minute. Any questions so far? Are you surprised by how many different techniques they have for sampling, although you don't know yet what all of them are like? And these are just the common ones. There are lots of other ones. I'm going to put in one right now. It's in my little list and I forgot it. And again, I forgot. What's good about this, it's pretty simple to do, right? You don't need an awful lot of information, right? Pretty simple to do. What's the bad thing about it? You can get bad data. Well, let's do the alphabetic one and tell you how you could get bad data from it. Do you know in Scotland, where I come from, the letter M is the biggest group of surnames in Scotland, because an awful lot of us are called Mick or Mac something. McPherson, McRobert, McEwan, McDonald. Can you see in this world of how we pick things, aren't we just going to pick one person, right, whose letter starts with an M? Nobody in Scotland who's Celtic in origin has a last name starting with a Z. So my prediction would be that aren't you undersampling the M's in the world and oversampling the Z's? Now that might not be a problem, but can you imagine it could be a problem, right? Especially if you were asking people something political. Maybe people who are Celtic would have one political view, and people who were not Celtic may choose a different one. I guess you could have problems with the houses. I can't imagine why the 10th house would be worse than the others, but maybe you're missing all the big houses in the middle, you know, just because the way the houses were being built. Now, convenience sample, which is in my list, I'm going to call it, I don't know, B+ because I missed it. That's when you just ask the first 100 people you see. That's an example of it. So a convenience sample. I want to know political views of people. So I just go to Safeway, and the first 100 people that walk in the door, I ask them. That would be an example of a convenience sample, right? I go to, when they used to have phone books, randomly open the phone book at one particular page, and I phone the first 100 phone numbers, right, of people in that list. Can you see a convenience sample is basically, its name tells you, it's easy to do and it's fraught with danger. So the only thing that it's good about it is it's easy. And the worst thing about it is the data is almost always bad. Can you imagine why you would just get bad data if you just went to Safeway or you went to, well, take that as an example. Suppose you were in Seattle and I went into Safeway or Pound Stretchers or something, right? Pound Stretchers. And I asked the first 100 people who they're going to vote for. And then I went into Nordstrom's and I asked the first 100 people I got there. Can you imagine that the political views of those two groups might not be the same? Can you? Yeah, you're just going to get. And if you go to the mall, aren't you probably not going to be asking people who've got a job? Because you know most people are working when you're at the mall. If you do it during the afternoon, so basically, I think it's not that list because the answer is don't do it. find something else. But the number of times that people do convenience samples and somehow think that the answer they got was really accurate and they want to tell you that it's the truth is amazing. Would it surprise you if politicians tend to ask people who believe the same as them so that they can then go and say 92% of people are in favor of insert thing here? Well, of course, if you only ask Democrats or if you only ask Republicans, aren't you going to get a distorted view? Or if you only go to a place where rich people live, or you only go to a place where poor people live, because it's easy, right? And you ask only people, you're going to have problems. So just ignore any evidence that somebody says they collected a sample and you know that it's a convenient sample. You know that they just took the easy way out. The next one is much more complicated to kind of describe. In a stratified sample, what you do here is you've got a random sample of people, but you choose the people according to at least 2 or 3 attributes. So I'll try and do it as a political one. Suppose I'm interested in how many people are going to vote Democrat or Republican in the next presidential election, right? I want to know what your political views are. That's a pretty straightforward one. Well, I could simply ask, 1,000 people and do a simple random sample. And that would be actually the best. But what they do in a stratified sample is they say, well, I want to make sure that I've got information on everybody. So the first thing they do is they would do states. So they would make sure that everybody, every state was at least represented a little bit. Now, you know that I hope I'm right, there are 50 states in America, am I right? Okay, so what you would have is over here, Alaska, and then try to think, Wyoming. Is there anything later in the alphabet than Wyoming? Not that really matters. Okay.
Alabama comes before Alaska, though.
Ooh, Alaska's. Thank you. Now, what you don't do is you don't say, there are 50 states, 1,000 people. That's all I can afford to ask because it's money, right? The more people you ask, the more money it costs you. Then I'm just going to ask 20 from each state. That would be a bad idea. And I'm going to put California in here. Why would it be a bad idea to split the 50 states and ask 20 people from each? Because that is a stratified sample, but a bad one. Why should you shouldn't do it that way.
Because the same amount, because places like California and Wyoming and Alaska have different amounts of people in them, different populations.
Right.
So you should ask based on the proportions of how many people live there.
Right. So I'm making this up because I don't know the proportions, but it might be you only ask 5 people from Alabama, 3 people from here, and 170 from California, right? So that is still a stratified sample. Would you agree that you're going to make sure that you ask every person from every state? In a simple random sample, it's just whatever you get, right? You might get, nobody from Alaska, right? It might just be the way the luck works. Now, once you've decided that's one of the strati, there a fancy word, one of the strati, one of the things, you then split each of the groups into another one. And this time you're going to do male and female. And can I pretend that's 6 just to make my life easy? And how does that work? Well, very roughly, you can get away with this. Half of them are male and half of them are female. And so in Alaska, which we're going to have to call 4 of them now, Can you see you do male and you do female, and there would be 2 of these and 2 of these, and here male and female, and what's that going to be, 85 and 85 and so on. So do you see what you've managed to do here is you're kind of taking your sample of 1,000 and you're making sure that you've hit 2 main things that you believe are big influences on voting. Do you know women and men tend to vote slightly differently politically, right? It's well known that that's true. Would you also agree that certain states are more Democrat and other states are more Republican? And so haven't we taken care of that? Now, why do they spend this? Because you can imagine that's going to be a lot more work than just randomly picking 1,000 people, right? Because don't you have to find 20 people in Alabama and 170 people in California and so on and so forth, right? So when you do that, why do they spend so much time? It's because the data doesn't just tell you a big picture. Doesn't it also tell you things like how California's doing? And if you go and you look at the data another way, doesn't it tell you males and females, you know, which ones are Republican and which ones are conservative? So they get a lot more information. So the good thing about it is you get more info. And it tends to be good data, provided you pick a big sample, right? Don't pick 50 people. Would you agree that that ain't going to work, right? You got to have 1,000. Right? And what's the bad thing about it? It's very complex. Would you agree it's quite hard and expensive? I guess I should put that in here, because it is. It's very expensive to do this. For instance, you have to find 170 people in California. Well, there's plenty of people, but don't you have to find them? And then it's not just that. Don't you have to make sure that 85 of them are male and 85 of them are female? Collecting that information's going to take people, a lot of time, right? And then they have to go and ask, and that in itself can be a problem. But it gives you really more info than a simple random sample does. And it has good data attached to it. You tend to get good stuff for it. Now, the next one, people very often confuse with the stratified sample. It's called this cluster sample. Again, take too long to write it, so I'll give you an example of one instead. Suppose I'm interested in doctors, just doctors' opinion. And let me qualify that. Doctors who work in a hospital, right? So not your GP, but a doctor that's in a hospital, right? So they might be a specialist in this field or that field, right? So doctors, right? Hospital doctors' opinion on abortion. Now, we'd like to ask a nice, simple, random sample, but it might be too awkward. It might be very difficult. Can you imagine how hard it would be to find every single hospital doctor that works there? So what a cluster sample does is you randomly pick, it depends what you want, say 10 hospitals. So I'm sure there's a register somewhere, isn't there, of every hospital in America. There's probably not a register of everybody who works in that hospital, or at least not one that's easy to get to, unless you phone up every hospital and ask them, right? But you should be able to find 10 hospitals randomly, would you agree? Then what they do in a cluster sample is you randomly pick 10 hospitals, and then you ask every doctor in only these 10 hospitals their opinion. You see how that works? Now you might say, well, that sounds a little bit like, the stratified sample we did, but it's not really, right? Okay, we're picking 10 hospitals, but once you pick the hospital, you ask everybody in that hospital. Do you see that's different? How's it different from this? Well, couldn't I have all the hospitals? or in this case, all the states. But don't I not ask everybody in each of the states? You see, I only ask a small group of people. So that's one of the major differences. This tends to be easier to do. Tends to be cheaper as well, so it's less expensive to do. The negatives are, if you pick, I'm trying to think of a word here, poor hospitals, and I don't mean hospitals with not a lot of money. Do you know, in Britain, and they might do it in America, who knows, but in Britain there are special hospitals called maternity hospitals. Do you have that in America? And maternity hospitals do one job. That's where mothers go to have babies, the ones that don't have them at home. That's all they do. Now, you can imagine you can't have maternity hospitals in small places, but big cities, reasonable sized cities, will have at least one maternity hospital. And now, the advantage of having a maternity hospital is, do you know that the doctors who deliver the babies have an awful lot of experience, because that's all they do. And don't they also, because of that, won't they have experience for unlikely or strange complications that may occur, that someone who only occasionally gives birth, you know, because their main job is, you know, the whole, you know, baby upwards or downwards, you know, they're a little bit more generalized. So they're quite popular in Britain because of that. Can you imagine that I picked a couple of hospitals that were maternity hospitals, right? Their job is, right, to birth babies, right? Couldn't you imagine that the opinion on abortion might be different than if I picked an abortion hospital? And so, if you know, I'm assuming you have places in America where you just go to have abortions, right? I call them hospitals. I wouldn't, but you know, people would, right? So you've got those things. If you're only picking 10 hospitals, aren't you fraught with danger that you might pick a couple of poor ones that are probably over populated with people you would expect to have a strong opinion one way or the other? And that tends to cause poor data. And we don't like poor data, bias data, right? We don't like that when it happens. But it is easier to do. And sometimes you just have to live with the fact that you can't always get what you want. I think we need a joke. You need a mental break, don't we? Yeah, okay. We got a few more to do, but we'll get there. Oh, Scotsman, Englishman, and American die. You know, it's a Scottish joke. People die. And they get to heaven, and St. Peter is showing them round. And it's a gorgeous place, as you can imagine. And it's huge, as you could probably imagine. And the Scots guy especially is really excited. He's saying, heaven is great, this is brilliant. And the Scots guy gets really excited and he says to St. Peter, how do we get around in heaven? It's so big. Do we all get a car? Do we get a car? And St. Peter went and said, well, strange, you know, funny you should say that. Yeah, everybody gets a car. The Scotsman's all excited and he goes, can I pick any car I like? Can I get any car I want? He says, no, it doesn't work that way. It depends how you were on earth. Depends how good you were. And we just decided on one question. And so the three of them are kind of interested and they say, okay then, are you ready? And they said, yeah, we're ready. So he goes to the Scotsman first and he says, how many times were you unfaithful to your wife? And he's got a little book. And the Scotsman says, I was never unfaithful to my wife. And he says, you're right. Got it down here. You never were. So the Scotsman says, what kind of car did I get? And suddenly, boom, a big fancy, you know, red sports car, open top, you know, gold rim wheels, the whole thing. And he jumps in and boom, he zooms off at 90 mile an hour. And he turns around to the American and, sorry, he turns around to the Englishman next. American was last. And he says to him, how many times were you unfaithful to your wife? And the American, I keep saying American, the Englishman got kind of shy, and St. Peter says, we know what it is. It's written down here. And he says, okay, it was just once and she forgave me. I never done it again, just once. And he says, you're right. He says, well, what kind of car do I get? And St. Peter says, well, you're not getting the same as a Scotsman. And boom, just a normal, sedan appears, and he gets in and drives away. And he goes to the American and asks him the same question. And the American's just looking down and looking left and looking right. St. Peter says, you got to answer it. How many times? And he says, 42 times. And he looks and goes, oh, you're right. He said, 42 times. He said, I don't know how I got into heaven. And St. Peter said, I don't know how you get into heaven either, but whatever. 42 times. So the American says, well, what kind of car am I getting? And he says, well, you're not getting anything like the last two, not based on that number. And so boom, this mini, a mini, tiny little car, American's 6'6". One of the doors is missing, the windscreen's cracked, there's rust everywhere, flat tires, you name it. It was a wreck. And he squeezes in and he kind of putters away. And the next day in heaven, they're at traffic lights and the Scotsman's in the middle. And the Englishman's on one side and the American's on the other. And they're looking at the Scotsman and he's crying away, crying his eyes out. And the American looks at him and says, what are you crying at? He says, look at the car I've got. And the Scotsman said, yeah, but I just saw my wife and she's using roller skates. Mark, are you married?
No.
No, okay. You got to be careful when you laugh at that joke if you are married. When you become married. Okay. Was that joke as bad? Is it that bad that you now want to go back to this so I can stop telling you them? Okay, let's get a move on. Yes.
I thought it was pretty funny.
Oh, thank you. I hope I didn't offend anyone. I don't think I did. So the next one is called random digit sampling. And this particular type of sampling is pretty modern. It's essentially impossible to do a random sample, a simple random sample, when you have a large population. The reason why it's impossible, there are just too many people and you don't really know everybody, right? It's very hard to know everything. And so one way around it is this thing called a simple digit, random digit sampling. And what they do is that they get a computer to randomly call people. You can get, what would they call them? You have the robocalling, right? Where basically they have a message, this is your candidate for Bremerton, vote for me, some kind of message like that. What they do is they just have a piece of software that randomly phones every digit that is likely to be in Bremerton or wherever it is, and you get these robocall messages. Most people hate them, I do as well. But this would be an example of that. The difference is that there is a person at the other side. So instead of somebody just, getting their phone and randomly hitting digits, can you imagine that you'd get an awful lot of failures? What the thing does is it randomly phones, and if there's no reply, it means that number's not used. And then it only keeps the ones that worked, right? And they get stored in a special database. And then those are the ones that phone them, and then somebody picks up the phone and they say, hi, I'm from Gallup Poll. We're doing a survey on, could you answer some questions for me? Random digit sampling. It's very inexpensive. And it's also, you get poor data from it. Well, tell you a couple of reasons why you get poor data from it. When you do random digit sampling, first, you're never going to phone someone who doesn't have a phone. So your sampling frames out, okay? Now, would you agree that people don't have a phone typically are going to be poorer than people who do? I'm sure there are a couple of billionaires that don't have phones, but in general, one of the reasons that you don't have a phone is you can't afford one, right? Second, do you know the amount of people who you might be able to phone, but the minute they pick up the phone and they hear who you're from, don't they put it back down again and they don't answer your questions? Aren't they the non-responders? So you tend to get large number of non-responders. People don't like to be randomly phoned, especially at dinner time, which seems to be the only time they want to phone me, right? And so, boom, there's another one, right? So when you put them into account, can you see why you get poor data from it? So why do they do it? It's actually very cheap. Do you know some of the polls that you will see on the news telling you about how the president is doing, or people's opinion of the Senate, or any of those kind of things? There's one company, I believe it's called Quinnipiac. It's got a funny name like that. Do you know they do the random digit sampling method? And it tends to come up with very weird data from time to time. Sometimes they get lucky and it's like everybody else, but sometimes it's way over the place. So my opinion, if you're looking at a survey and it's from this Quinnipiac company, you should probably not pay a lot of attention to it. Mostly because this causes all sorts of randomness and tends to be poor data. How are we doing? Almost done. Internet panel sampling. This is even more modern than that because it only really became a thing when the internet took over, right? When almost everyone is on the internet. Well, an internet panel survey is different from the top. I didn't do this. Have you ever been to a website that asks you your opinion? You go to a website and they say, how are we doing, right? And it might be just, I want to know how this website is doing. But have you ever been to one where a thing pops up and says, we'd like to know your opinion of abortion, or we'd like to know this or that? You've just became a member of the internet panel sample, right? Can you see that basically they use the internet and they get that? Now they can do, there are lots of variations in this. One of them is if you just turn up on the site, there's a sample there, right? Have you ever heard a radio show where the guy would say something like, go to our website and, vote here? That would be another example of an internet panel sample. If you went to the Republican, I don't know if they've got one, I'm sure the Republican Democrats have some list, but if you went to the Republican main website, wouldn't there be a very good chance that there'd be a little sample here, there, or somewhere? That's an example of it. Why are these bad? Well, can you imagine if you turned up to the Republican main website, there's a very good chance you're a Republican. And if you turned up to a Democrat website, isn't there a very good chance that you're going to be a Democrat? So can you see, whatever they ask you there, isn't the answers going to be biased because the people you're asking have a particular political opinion, right? Now, you might say, well, what about other sites? Well, even they can be a problem. Would you agree that some news sites are more liberal and other news sites are more conservative, right? So if I went into Clinton Network News, CNN, aren't the chances are I'm more likely to be a Democrat than a Republican? And if I went to Fox News, aren't I more likely to be a Republican than a Democrat, or conservative and liberal, if you want to use those terms? You see how internet panel. Now, which ones might be good? If I turned up to an internet site that was interested in Seahawks football team, would you agree there's a good chance that there's not really a political affiliation if you like the Seahawks, right? So if they did ask a question there about politics, it'd probably be okay, right? But they are cheap, easy to do, right? Again, it's almost all of them. And sometimes, if you're not careful, you get biased data because the people you ask are biased. And then to finish with, we have multi-stage. Probably the easiest one to describe. See if you make up a method that is kind of a combination of 2 or 3 of these methods. Then you're doing a multi-stage one. So you might decide that you are going to randomly, simple random sample a state in America, right? So that would be simple random sample, right? 50 states, and I randomly pick California. And then once I've decided I'm only going to look at California, that's the simple random sample bit done. Couldn't I then systematically pick one town in California starting with an A, one town starting with a B, right? One town starting with a Z. So wouldn't that be a little bit of a systematic going on then? So in California, I've got 26 towns, and then in those towns, I randomly digit phone people who live there. You see, I'm using a bit of 3 different techniques. And there is, well, theoretically, isn't there an infinite number of ways you can do a multi-stage? It's hard to say whether it's good data or bad data, doesn't it? Depend on what kind of sampling you do, whether it's a good one or a bad one. So it's kind of variable. So I'm not going to put down here anything about pluses and minuses. I think the negative is, would you agree it becomes really complicated if you do a multi-stage sampling and there's 5 layers to it? Like you have to do 5 things before you pick the person or persons. And that's perfect timing for me. You survived it.